Hello and welcome to all students. This is FYBSc semester 2nd class, paper number 1, calculus 2nd, unit number 2, differentiability of a function. And today we are going to study about algebra of differentiable functions. In this article we will prove that various algebraic combinations of differentiable functions these algebraic combinations are generally differentiable. We will also derive rules of finding the derivatives of these combinations, and today we are going to prove some theorems based on algebra of differentiable functions. So let us write the statement of the theorem. So theorem number 1, first theorem, if f from I to R, if f is a function from open interval I to the set of real number R, and g is also a function from the open interval I to the set of real number R, and these two functions are differentiable these two functions are differentiable at point P in the open interval I, then first statement is for some C belongs to the set of real number R, C into F is differentiable at P, and derivative of C F at point P is equal to C into derivative of F at point P. So this is our first statement of this theorem, and now we write the second statement is the addition of F and G is differentiable at P and derivative of f plus g function at point P is equal to derivative of f at point P plus derivative of g at point P. So this is our second statement. Now let us write the third statement. F into g is differentiable at P, and derivative of f into g function at point P is equal to f dash at P into g of P plus f of P into g dash at P. So this is the product rule of derivative. And the fourth statement of this theorem, is f upon g is differentiable at P, f upon g is differentiable at P provided g of P is not equal to 0, provided g of P is not equal to 0, and derivative of f upon g at point P is equal to f dash at P into g of P minus f of P into g dash of P and whole divided by g of P its square. Okay. Okay, so this is the statement, four statements which we are going to prove. So once again we read this theorem carefully. So if f is a function from I to R and g is a function from I to R are differentiable functions at point P belongs to I, then for C in R, any C in R, Cf is differentiable at P and Cf dash at P is equal to C into f dash P, and f plus g is also differentiable at P and g plus f plus g dash at P is equal to f dash of P plus g dash of P. Third statement is f into g is differentiable at point P and f into g dash of P is equal to f dash P into g of P plus f of P into g dash of P. Okay, and fourth statement is f upon g is also differentiable at point P provided that g of P is not equal to 0, and f upon g dash of P is equal to, means the derivative of f upon g function at point P is equal to f dash P into g of P minus f of P into g dash of P whole divided by g of P square. Okay, so these are the four statements which we have to prove. So let us write the proof of these statements one by one. Let us, so first of all we write what is given to you. So write down proof. So in this proof, first of all we write f and g are differentiable at P. This is given to you. So we write given that f and g are differentiable at P. Okay, therefore we have the first limit of f of x minus f of P divided by x minus P as x tends to P exist, this limit exists, and is equal to f dash at P, means derivative of f at point P. Second statement is says that the limit of g of x minus g of P whole divided by x minus P as x tends to P, this limit also exists, and that limit is equal to g dash at P. Okay, so this is given to you. Okay, and the first statement which we want to prove is, so let us take first statement now. First statement is, consider the limit of the function Cf at x minus Cf at P and whole divided by x minus P as x tends to P, and it is equal to limit as x tends to P cf at x is c into f of x minus cf at p means c into f at p, and whole divided by x minus p. From this limit we can take c common outside of limit x tends to p, and what we get is f of x minus f of p and whole divided by x minus p. Okay, and it is equal to c into this limit is nothing but f dash at p, or this we can write cf. Okay, so thus we write cf. Okay, so this exist, but exist means this is nothing but the limit of cf dash at p, and that limit is equal to c f dash at p. Okay, so this is our first proof. Okay, first statement is proved. Now we prove the second statement. Okay, and second statement, to prove the second statement, consider the limit f plus g of x minus f plus g at p as x tends to p, and is whole divided by x minus p. It is equal to limit as x tends to p. So f plus g of x means f of x plus g of x, minus f plus g of p means f of p minus g of p, and whole divided by x minus p. Okay, so let us we write this limit x tends to p. Okay, so we can separate this denominator to the two terms, means f of x minus f of p, and this whole divided by x minus p, and plus g of x minus g of p, and this whole divided by x minus p. Okay, we separate this limit to these two terms. The next step, we write limit as x tends to p of f of x minus f of p, and whole divided by x minus p, plus limit as x tends to p g of x minus g of p, whole divided by x minus p. And we know that the value of these two limits exist, and this limit is nothing but f dash at p, plus this limit is nothing but g dash at p, means derivative of g at p. This limit is derivative of f at p, and both exist, and this I can write g. Okay, so thus finally we can say that this exists, but that limit, left hand side limit, is nothing but it is g, or it is, thus we write here, thus f plus g dash of x, or f plus g dash at p, is equal to f dash at p plus g dash at p. Okay, so this rule of differentiation we can state in other words: derivative of addition of two functions is equal to addition of their derivatives. Okay, so this is our second statement and we have proved that statement. Let us go to the third statement to prove. Third statement, to prove this third statement we consider the limit, as x tends to p of fg of x minus fg of p whole divided by x minus p, it is equal to limit x tends to p f of x into g of x minus f of p into g of p divided by x minus p, it is equal to limit x tends to p whole divided by. So let us we add some term and subtract that same term. So see here for our adjustment, f of x into g of x minus, we see here right, f of x into g of p, okay, plus f of x g of p and minus this final term I write here, f of p into g of p, okay, and whole divided by x minus p, okay, equal to limit as x tends to p. Okay, now let us take together these two terms. Okay, from these two terms we take common f of x. Okay, f of x is common and inside the bracket g of x minus g of p. Okay, and from these two terms we take common plus g of p, and inside the bracket there will be f of x minus f of p and whole divided by x minus p. Okay, now okay, now it is equal to, now in the next step what we will do is okay, so the adjustment should be, here must be f of p. Okay, so we make some correction in the adjustment. So here should be f of p and here also here should be f of p. Okay, so that okay, from first two terms we take outside f of p. Okay, no problem now. Now let us separate the limit. Let us separate the limit here. Limit x tends to p, or I can write just here. Now we observe that f of p into g of x minus g of p whole divided by x minus p plus g of p into f of x minus f of p whole divided by x minus p, and we take the limit of both the terms. F of p is constant and limit of this term with respect as x tends to p is g dash at p plus g of p is constant as it is, and limit of this term, okay, limit of this term with respect to p is f dash at p, and this limit exists. Okay, so this is our final answer and this term exists. Therefore we say f into g dash of p is equal to f of p g dash of p plus g of p f dash of p. Okay, so product derivative of product of two functions is equal to f of p into g dash of p plus g of p into f dash of p. Okay, means first function as it is derivative of second function plus second function as it is derivative of first function. So this is the product rule of differentiation. Now I would like to give one homework. So try to prove this fourth statement. Fourth statement means it is homework for students. Derivative of f upon g with respect to p, and that derivative must be equal to g of p into f dash at p minus f of p into g dash of p whole divided by g of p and its square. So try to prove this statement at your own. Okay, and this is the end of our lecture, and thank you very much for paying attention.